Testing. All right, Math 0099. We're continuing with review today. So I'm picking up topics from chapters 1, 2, and 3, I guess, through 4.2. 4.3 is where we began officially with our new content. So we were looking at order of precedence with respect to multiple operations within one expression or equations. So we're supposed to evaluate and I obviously have multiple operators, so I'm going to call on my little cheat sheet. Please excuse my dear Aunt Sally. Priority is parentheses, exponents, multiplication and division, remember, whichever is presented first from left to right, and addition and subtraction, whichever is presented first from left to right. So I'm looking and scanning for parentheses. I don't see any. I do see exponents, so I'm just going to highlight that and work on the exponent. Copy everything else down the same. 4 squared, 4 times 4, 16. Scanning, I'm looking for multiplication and division from left to right. So as I move across, here's multiplication. 3 times 29. So 7 plus 3 times 29. 87 minus 16. Copying everything else down the same. I'm doing one operation, one step at a time. And I just do leave this mark. That's so I can trace my work or double check my work. I don't see any more multiplication or division. I can check that off. And now addition or subtraction from left to right. Starting on the left side, the first presented is addition. So 7 plus 87 is 94. Minus 16. And my last step is to subtract 16 from 94. I get 78. So the process we're going to be reviewing yet today, order of precedence. Without establishing our order of precedence, we have no order to determine an accurate result. Supposed to calculate 100 divided by 20 divided by 2. Please excuse my dear Aunt Sally. There's only division, and again, multiplication and division I do from left to right as presented. So there's division. 100 divided by 20 is 5. Copy everything else down the same. Still division. 5 divided by 2. Let's see, that's 5 divided by 2 for 5 halves, or 2.5. $1,000 divided by 1/10 times 4/5. So please excuse my dear Aunt Sally. No parentheses, no exponents this time. We do have multiplication and division, and presented from left to right, division is first. So we're going to divide. Now we have to remember how to divide when we're dividing fractions. So we divide by changing division to multiplication and multiplying by the reciprocal. Copy everything else down the same. All right, I still have multiplication here. 1,000 in fraction form is actually 1,000 over 1. Multiplication of fractions is a piece of cake. Multiply the numerators. Multiply the denominators. Copy everything else down the same. Now I have multiplication left. This is multiplication of fractions. I have 10,000 over 1 as a true fractional form. It's a whole number in fraction form with a numerator and a denominator. So I can go ahead and multiply. Multiplication of fractions is a piece of cake. We multiply the numerators, multiply the denominators, and simplify if we can. And 5 goes into 40,000, 8,000 times. The trick here is to remember that division of fractions. We change division to multiplication and multiply by the reciprocal. Five times the quantity, 14 minus the quantity 8 plus 2, close angle bracket. So when I'm making use of my grouping symbols, angle brackets, parentheses, and braces, they have to be nested with each other, and each comes with an open and a close. So the angle bracket within, I have a parenthesis and a parenthesis. We're supposed to evaluate. Well, again, please excuse my dear Aunt Sally. Parentheses. Well, actually, I have my grouping symbol for angle brackets, and within I have another set of grouping symbols. We always work on the innermost set first. Copy everything else down the same. 8 plus 2 would be 10, and that parentheses set is resolved. 10 is a constant. There's nothing more that I can do, so I can remove that innermost set of parentheses. Looks like I'm still working with a set of grouping symbols. I have my angle brackets, so I'll work within the next set of parentheses. 5, 14, subtract 10 would leave 4. There's no exponents, multiplication and division. This is 5 times 4, which is 20. So neatness, consistency, write down the page step by step. Don't work across. I know sometimes you're trying to save paper. There's lots of scratch paper around the campus. You can pick some up in the library very easily, but work down rather than across as you're solving your problems. One-sixth times the quantity, in parentheses, 3 cubed minus 3, close, plus 12. Close angle bracket. All right, just scanning, I have angle brackets, and within I have my open and close parentheses, so they're nested correctly. Please excuse my dear Aunt Sally. Well, I see parentheses, and within my grouping symbols, there's an innermost set of parentheses, so I'll act on that first. 3 cubed. I have a calculator. 3 raised to the third power is 27. 3 times 3 is 9 times 3. 27 minus 3. Copy everything else down the same. This is a hint and a tip, but at this level, we want to make sure every step is correct and don't want to miss a step. Sometimes trying to work ahead or mental math at this point, we're easily missing some logic. And after all, your calculator and Google do this the same way, one step at a time, except at nanosecond speed. All right, so we still have a nested set of parentheses. Let's do that next. 1/6 times the quantity. 27 minus 3 is 24. That is a constant, so I can remove the parentheses. There's nothing more I can do to further simplify that. Looks like I'm still working in parentheses. 1/6 times the quantity. 24 plus 12 is 36. I have no more parentheses. Exponent, multiplication and division from left to right. Everything okay? 6 goes into 36 6 times.
Yes, some student cannot hear you. Maybe it's from the other connect.
It says.
Your microphone.
How do I get there?
Oh, no, that's, yeah, that's good.
Testing. Testing.
Yeah.
Sharing, okay. I don't know.
Yeah.
Can you hear me now? Nobody else is on the other side. I'm sorry?
No. Okay, that looks right. That works.
You think it's okay?
Yeah.
All right. Okay. We're still evaluating expressions using order of precedence. I have multiple operators, so I'm going to use my cheat sheet again. Parentheses, none. Exponents, none. Multiplication and division from left to right as presented. Multiplication is first. 15, subtract 2 times 5 is 10 plus 3. No more multiplication or division. Addition and subtraction as presented from left to right. Looks like I have subtraction first. 5 subtract 10 is, or 15 subtract 10 is 5 plus 3. And finally, I can add 5 plus 3 is 8. Evaluate 3 times 4, the quantity squared. 3 times 4, the quantity squared. Please excuse my dear Aunt Sally. I have parentheses, so I'll work within them first, and 3 times 4 is 12. Copy everything else down the same. And 12 squared. 12 raised to the second power is 144. Three times 9 squared. Please excuse my dear Aunt Sally. No parentheses, I have exponents. 9 squared. 3 times 9 squared is 81. 9 times 9. 3 times 81. 243.
This is Jensen.
So that takes us through 4.1, I guess. So now we'll just kind of start reviewing chapter 4.1 and point 2, and then get busy with section 4.3. So we're fine-tuning our exponents in chapter 4. And you're introduced to exponents as a base raised to a power, which we've already been experimenting with some problems with exponentiation. A base raised to a power, we know it's a shortcut for multiplication where the base has to be the same times itself a given number of times. And we know when we introduce something new, it's likely there's special cases. So we say that when we have a base raised to the second, it's the base times the base. Base times itself 2 times. Base cubed, base raised to the third power is base times itself 3 times. Base to the first power, which we typically don't write the exponent, we understand that it's the base to the first power, is equal to the base itself. And then the base raised to the 0 power is equal to 1 by definition. So that means we have to memorize that. It's by definition. So I think of my base 10 because I work with base 10 most frequently. You've studied base 10 for many years. It kind of follows along our currency. 10 cubed would be 10 times 10 times 10, which is 1,000. 10 squared would be the base times itself 2 times, which happens to be 100. 10 is 10. 10 raised to the first power is 10. 10 to the 0 power is 1 by definition. And then 10 to the negative 1 would be 1 power of 10 less, as we're counting down a power of 10 with each exponent. So we take the base to the denominator, and if I do one thing, I have to do something else to keep things balanced. Take the base to the denominator and change the sign of the exponent. So negative exponents. And that's likely going to be new material for you. So right now we want to make sure we know our positive exponents when we're working with a base raised to a power. And we kind of have a little idea what's going to happen when we start using negative exponents as well. So 5 to the first is equal to 5. A negative 8, the quantity raised to the first is, well, I have a clue. I have a negative base. I have a negative base and it's raised to the first power, so it's equal to the base itself. 3 raised to the 0 power is 1 by definition. 186,432 raised to the 0 power is equal to 1 by definition. So then we begin to look at expressions where we have exponentiation involved. And we're supposed to solve when x equals 5. So I'm very carefully going to copy everything down the same, and for every occurrence of x, I'm going to substitute 5, but copy everything else down the same. Careful substitution into our expression, and we're going to, at this point in time, let x equal 5. So I have 5 raised to the 4th power, 625, 1,000, subtract, and I'm working on my exponents first. 5 to the 4th is 625. 5 times 5 is 25, times 5 is 125, times 5, 625. And then subtracting, I get 375. Here we are looking at solving the area of a circular region. So we're talking about the area of a circular region. We're going to use pi, and r would represent the radius of our circular region. We're supposed to solve when the radius is equal to 6 centimeters. So careful substitution. For every occurrence of r, I'm going to substitute 6 centimeters, but I need to square it. Pi, they usually will tell you to use pi to some given accuracy, and they said use pi approximately 3.14. So we're going to substitute 3.14 for pi, although we know it's an irrational number. Oh, hi. Glad to see you. You'll probably be joining my YouTube channel.
There's a student that just called and said they can't see the problems. So, we got Elias, he's gonna.
That's very good.
Wow. Let's see. Can I?
Yep.
Wait, YouTube channel?
Did you?
Yeah, I got that too.
Did you share the screen? Oh, shoot. Okay. Can we do that?
Yeah. So how do I know? Oh.
Yeah. Why did you see that?
Okay, magic. That should be working for you. Thank you for calling. So, reviewing, we are working on the problem of the area for a circular region. A equals pi r squared when r equals 6 centimeters and pi is approximately 3.14. Careful substitution. Pi, we were told to use 3.14, and centimeters, the quantity squared. Area is equal to 3.14 times 6 times 6 is 36. And centimeters times centimeters is centimeters squared. And with my calculator, 3.14 times 36 is 113.04. Centimeters squared. Remember, with any story problems that you label your unit measurement, and with area, your result is in unit squared. At Google, we've talked about our calculator there. Just some expression in the text box will resurrect your calculator. And we had 3.14 times 6, and there's your base raised to an exponent key. You see it populates. Google nicely does the exponent superscripted. Likely on your calculator you won't see that. And our answer is 113.04, and of course you need to manage labeling. Okay. We have the quantity 5x raised to the third power. We have a clue. Our base is 5x, the quantity cubed. So that means I have my base times itself 3 times. 5 cubed is 125, and x cubed is x cubed. Now what happened here, I have a base raised to a quantity. This is actually 5 to the first power. This is x to the first power, and I multiply exponents. So I got 5 cubed. 3 times 1 is 3, and x raised to the 1 times 3 is 3. And then I solved 5 cubed. A base raised to a power, the quantity raised to a power, we multiply exponents. We're supposed to solve 5x cubed when x equals a -2. Here I have 5 times my base raised to an exponent. I'm going to very carefully copy that down and then substitute. I have 5x is a -2. I'm going to protect the sign, and raised to the third power. Five times a -2 cubed. Well, that's 5 times. I have a base raised to a power, and I have a clue. I happen to have a negative base. That's -2 times -2 times -2. A negative times itself an odd number of times is going to result in a negative. 2 times 2 is 4 times 2 is 8, so -8. So I have 5 times, resolving my exponent, a -8. 5 times -8 is -40. 5 squared times 5 cubed. Product rule for exponents. I have the product of the same base. The product of the same base, so I add exponents. Get 5 to the 5th. And why does that work? 5 times 5 is 5 times 5. 5 cubed is 5 times 5 times 5. 1, 2, 3, 4, 5. That's the shortcut for exponents. Equals 5 to the 5th. The product rule. Product, we're multiplying. When you multiply with the same base, we add exponents. Okay, m to the 5th times n to the 10th times m cubed would be m to the 1518. Product rule, same base, add exponents. X times x to the 8th. Well, I have the same base in multiplication. Product rule, same base. X is actually to the 1st degree. We don't write that exponent, but we know and understand it's to the 1st degree. So adding exponents, I have the same base in multiplication, I get x to the 9th. A cubed b squared times a cubed b to the 5th. Well, this is a cubed times b squared, and this is a cubed times b to the 5th, and this is this quantity times this quantity. It's all multiplication. So I can rearrange using the commutative law for multiplication. As long as it's all multiplication, 3 times 4 is the same as 4 times 3. So I can rewrite this as a cubed times b squared times b to the 5th. I just kind of collected my a terms and my b terms. And now I have my product rule, same base in multiplication, add the exponents. Same base in multiplication, add the exponents. Six to the 5th over 6 cubed. It's our quotient rule for exponents. Quotient is our result when we divide. Quotient rule. Let's see, 6 times 6 times 6 times 6 times 6 over 6 times 6 times 6. Right here I see another name for 1. 6 cubed over 6 cubed is another name for 1, leaving 6 times 6, which is 6 squared. But we don't want to do all of this manual labor when we have the quotient rule that says 6 to the 5th over 6 cubed, 6 to the 5th, bring the base to the numerator and change the sign of the exponent. And now I have my product rule, same base, add exponents. 5 plus a negative 3 is 6 squared. Quotient rule. After all, we're subtracting 6 cubed as another name for 1, leaving 6 times 6, 6 squared. In fact, we can get more efficient. 6 to the 5th over 6 cubed. I see the quotient rule. I have the same base in the numerator and the denominator. So keep the base and subtract from the numerator the denominator's exponent. The quotient rule. Like bases in division, subtract from the numerator's exponent the denominator's exponent. X to the 8th divided by X. Obviously, we're dividing, it's a quotient rule, and I see like bases in the numerator and the denominator. So I'm going to keep the base and subtract from the numerator's exponent the denominator's exponent, which is 1. Now, does that make sense? We have x times 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 x. 1, 2, 3, 4, 5, 6, 7, 8 divided by 1x. There's another name for 1. What's left? X times itself. 1, 2, 3, 4, 5, 6, 7. So instead of doing all this manual labor, we want to make use of our quotient rule. That is, if you have like bases in division, subtract from the numerator's exponent the denominator's exponent. Okay, I have division of the same base. 3t is my base in the numerator and 3t is my base in the denominator. So I'm going to keep my base and subtract from the numerator exponent the denominator's exponent. And every once in a while, your author changes things up. So we use our A's and B's and P's and Q's. Well, this is multiplication, so I have P to the 5th over P squared times Q to the 7th over Q to the 5th. Division, I see the same base in the numerator and the denominator, so I'm going to keep the base and subtract from the numerator's exponent the denominator's exponent. I see the same base in the numerator and the denominator, so I'm going to subtract from the numerator's exponent the denominator's exponent. And as you work with this a little more, you could probably save yourself with a mental math step or two. And then negative exponents. Any base to the negative n is equal to take the base to the denominator and change the sign of the exponent. So 7 to the negative 3 times 7 to the 6th. I have a base raised to the negative exponent, so I take the base to the denominator and change the sign of the exponent. 1 times 7 to the 6th would be 7 to the 6th over 7 cubed. Now I have the same base in division, so I keep the base and subtract from the numerator's exponent the denominator's exponent, and end up with 7 cubed. Five to the 4th, subtract 5 to the negative 2. I'll have the same base in the numerator and the denominator with division. So I keep the base and I subtract from the numerator the denominator's exponent, which happens to be a negative 2. Subtract from the numerator's exponent the denominator's exponent. It happens to be a negative 2. Now I have 5 to the 4th. Change subtraction to addition and add the opposite. I have negative 2. Its opposite would be positive 2. I have a negative 2 and I'm asking for its opposite. Negative 2 and I'm asking for its opposite. That'd be 4 plus 2, which is 5 to the 6th. And x over x to the 7th. Just remember that this is x to the 1st degree. I have the same base in the numerator and the denominator. My quotient rule holds. Keep the base and subtract from the numerator's exponent the denominator's exponent. So x is a negative 6. X to the negative 6. Now a note at my math lab for your homework and testing: most often, my math lab will say, show your final answer using only positive exponents. So we're not quite ready to circle our answer. We need to convert this so that we have a positive exponent. So I have x to the negative 6 if I take x to the denominator and change the sign of the exponent. Now I have my answer formatted as my math lab wishes, using only positive exponents. Then b to the negative 4th over b to the negative 5th. I have division using exponents, and I see that I have the same base in the numerator and the denominator. But this is b to a negative 4, so I'm going to take that base to the denominator and change the sign of the exponent. And this base is in the denominator's position with a negative exponent, so I'm going to take the base to the numerator and change the sign of the exponent. And now I have the same base. I'm going to subtract from the numerator's exponent the denominator's exponent. And that leaves b to the 1st degree. Y to the negative 4 times y to the negative 8. Well, that's my product rule. Multiplying, same bases. I keep the base, and the product rule, add exponents. Negative 4 plus a negative 8 is a negative 12. And just be careful, reminder at My Math Lab, always before you circle your final answer, make sure you read how they want you to display it. They may want you to show your answer using fractional form, which means you need a numerator and a denominator. They may say they want your answer rounded to 3 places following the decimal point, not 2. They might say show your answer using only positive exponents. So we have to convert our answer yet. So our final answer is going to be take the base to the denominator and change the sign of the exponent. You can circle your final answer. Okay, we're looking at the end of section 4.1 for review. We'll review section 4.2 next with some applications. Be sure to return to D2L. Open the overview document where I journal with you for any homework, assignments, testing, all the details and due dates. We are still in review mode, so no homework has been assigned, but you have a syllabus quiz, an attendance quiz, and all of your personal device set up and establish your profile at My Math Lab. All right, thank you very much.